So this is our 16th lecture about estimation ARDL ECA model in Stata. I will also share the link of Stata. You please keep in your mind. I will send you the link of Stata software to be downloaded by you with key, with everything you can download by self. The general form of ARDL model, there are two things are here. The first one is ARDL model, the second one is estimation method. We will estimate ARDL method, ARDL model, this ARDL model by ARDL estimation method technique. So here, YT is a function of gamma 0j plus summation I 1 from 1 to p. This one is the you can write down here. This is a depreciation sign, I think, depreciation sign. J YT minus 1. It means 1. I will this one will be explained later. Plus summation I from 0 to q beta j xt minus I plus error term. Here y t is a vector and the variables yt is a vector. Vector means is a mathematical term. In vector you find one column many rows. वेक्टर में बेटा एक कॉलम होता है, रोज होती है बहुत सारी. ठीक हो गया. इन अदर वर्ड्स वेक्टर में आप सारे वन बाय वन वेरिएबल्स आप डिपेंडेंट वेरिएबल हो, वन बाय वन वेरिएबल हो गए. एंड द वेरिएबल्स इन xt are allowed to be purely integrated order 0 or integrated order 1. बेटा ये अभी कोई इतना अभी आपको पता नहीं चलेगा. ये integrated order mean we will apply ADF test or augmented decay flow test when all variables which are whether they are dependent or independent, if they are integrated at any order, at integrated order 0, integrated order 1 or integrated order 2, no matter. Okay. So here yt is your dependent variable. I am going to explain, you please understand. Yt is your variable, dependent variable, is a vector of dependent variables. Okay. Yt minus 1, t minus 1, here I mean from 1 to p, from 1 to p. T minus 1 mean 1 lakh. For example, yt is period time period. For example, t is 2010. Then t minus 1 mean 2009. Okay. T minus 2 mean 2008. T minus 3 mean 2007. T minus 4 mean 2006. T minus like this. I think you understand everything. Yt, for example, if yt is 2000, for example, 19, then t minus I is a term which ranges from 1 to p. Okay. So I range from 1 to p, t minus 1, t minus 2, t minus 3. T minus 1 mean if yt is 2010, yt is 2010, then t minus 1 mean 2009, t minus 2 mean, okay, it means this is a model, it needs some explanation. For example, t mean 2015, 2015, then t minus 1, 2014, and this one is the coefficient of t minus 1. This is the coefficient yt minus 1. Then next one is the same thing, but I over here. Here I mean I range from 0 to Q. 0 to Q. We will do here. For example, t minus 0, then xt. T minus 1, then we will do later. Okay, for example, here t is 2015. Then when you will build model, then step by step you will take next. If I 0, then t is 2015. If I 1, then t minus 1, 2014. Getting the point? Step by step you will take values. Okay, here are here beta and gamma, beta and depreciation sign. This one is this one. These are beta coefficient. अब कोफिशिएंट क्या एक्सप्लेन करते हैं? कोफिशिएंट ये बताते हैं कि एक्स टी माइनस 1, वाई टी माइनस 1, वाई टी को कितना अफेक्ट करते हैं, वाई टी को कितना अफेक्ट करते हैं. Here the gamma is the constant. Gamma is constant. J, this one is the J. Coefficient of beta. It 1 to K. 1 to K. PQ are optimal lag orders. PQ are optimal lag orders. This one beta. Lags. Lags mean previous lags. This one can be future lags, but here negative sign is the past lags. These are the past lags. Okay. Wait. Tara, you all entry देखना. Yes. जी बेटा. Now these are the lags, past lags. PQ are the optimal lags. Here EIT is a vector error term. Observable 0 means quite nice error term. Here dependent variable is the function of its lag values. The current and lag values of the exogenous variable. Dependent variable is the function of its own lag values, exogenous current and lag values in the model. The lag length is here for PQ. Lag value is here P and Q. P lags used for dependent variables. Q lag used for independent variable, that is exogenous variable. These are the exogenous variables. Okay, but this is a just explanation. This is a just explanation for you about the model. Just explanation of the model, please. Okay, never confuse about it. Just explanation. Now, so here are the second one is the bound testing, bound test for co-integration. Bound test for co-integration. That to perform the bounds test for co-integration, the conditional ARDL model with three variables specified here. You can do four other variables also. Never mind. Bound test for co-integration, it means and explains that whether long-run relationship between dependent variable and independent variable is hold or not. बाउंड टेस्ट में आपको ये बताता है कि डिपेंडेंट वेरिएबल और इंडिपेंडेंट वेरिएबल में क्या लॉन्ग रन रिलेशनशिप होल्ड करता है या नहीं करता. There is some conditions. First one hypothesis is that these are the models for three models. Models are same. The first one is dependent variables change independent variable wait hello okay beta okay ठीक है चेंज कर oh यार जी बेटा let's see to perform the bound test. Basically bound test for co-integration explains that whether long run relationship between dependent variable and independent variable is hold or not. बाउंड टेस्ट हम क्यों हम कैलकुलेट करते हैं, बाउंड टेस्ट हम क्यों अप्लाई करते हैं. बेसिकली बाउंड टेस्ट हमें ये बताता है कि क्या डिपेंडेंट वेरिएबल और इंडिपेंडेंट वेरिएबल में लॉन्ग रन रिलेशनशिप होल्ड करता है नहीं करता. ये इसका बेसिक पर्पस है. मेरी बात हियर मॉडल बेटा आप देखें, please see the model. Change in ln mean the log, natural log. This is a natural log. Let's see. ln MVA. MVA one variable. Any variable, you don't worry about that. What is the variable? Okay. Then dependent variable is its lag, its current and lag values. Its lag values. You place its lag value. T minus 1, beta 1, 1. Yes. Then beta 2, 1 for second very. In the black colored, you can see, in the black colored, you can see the dependent variable, the exogenous variable. In the red color, light red colored is the lag of dependent variable. Is the lag of dependent variable. Okay. Then plus change and lag. Change and lag of dependent variable. Not only lags, plus change and lag of first dependent variable. Then change and lag of second dependent variable plus error term. Here, very important thing, I from 1 to n. Here I range from 1 to p. Here I for second variable I from 1 to q. Here beta very simple. Then change in dependent variable, change in lag of dependent variable. T minus I mean I from 1 to p. Lag of dependent variable from 1 to p. I j from I mean coefficient of first lag. J mean which one we have done? J mean from 1 to n. This is a coefficient. Here you can see here D1ij. J from 1 to 3. This is the coefficient. Now, but I'm going to the relationship. Please come on here. Beta 1, 1. If J 1, if beta 1 means first coefficient, second coefficient, third coefficient. Beta 1j, beta 2j, beta 3j, beta 4j. Here J mean from 1 to n. But actually this is the matrix. I think require little detail. Maybe, but you can write down this methodology. Beta 1, 1. Beta 2, 1. Beta 3, 1. This is the first column. Then the second column. Then the third column, you can do by self, but it is a little difficult for you. But now I'm going to next to explain for you. Here you will find now you will see this table in the estimation. In the estimation result, you will see this table. So if f statistics values is so you will find over there f statistics values and t values. This is the f statistics calculator values. If this value is less than tabulated values, then you will say no longer relationship is hold. But only in one case, f calculated value is greater than the tabulated values, then we say long run relationship is hold. Long run relationship is hold. Now we are going to next. Now we have to estimate ARDL. If there is no co-integration, the ARDL model is specified. If there is co-integration, the error correction representation is specified. Okay. In the first sequence, we find no co-integration is hold. Then this model will be then this ARDL model will be estimated. This is the better your specification. You can write this specification.